Hi, Vera Mays here from the Learning Commons. It's time for our Math 1033 workshop for the week. This week we're talking about systems of equations. I don't have anyone here yet, so I'm going to go ahead and just work a couple examples. And if you have any questions, if you're watching from home, go ahead and put it in the comments, and I have somebody here that can let me know, and we'll make sure we get your questions answered. Otherwise, if this doesn't do the trick for you, come on in and we'll be more than happy to help you with your problems. All right, so I have 3 examples today. And we're going to look at each one of them. They're slightly different, but they're all good examples for what you have to do for your homework and your test. You're learning 3 ways to do this in this class. One by graphing, one by substitution, and one by elimination. So I chose to kind of focus on the substitution and elimination today. So the first one is a good example of when you would use substitution. If you notice by looking at the 2 equations, one of the variables would be fairly easy to get by itself. So if I look at this second equation and I subtract 3y from both sides, I have x by itself, and I can substitute that into the other equation everywhere I see an x. So I have 4x minus 3y equals -1. This x is going to become 11 minus 3y. Minus 3y equals -1. And now I'm going to focus on the y's. And when I get done, I have to make sure if I have an answer for the x and y since it's a system. So we're going to go ahead and do the substitute. Go ahead and distribute and add up like terms, and let's see what we get for y. So I'm going to go ahead and distribute. And add up like terms. And I want to be able to solve for y, so I get my y by itself by subtracting 44 from both sides. So I have -15y is -45. Last thing, to get the y by itself, I divide both sides. I got -15. Cancels on the left side, and I get y is equal to +3 because I have a negative over a negative. Your answers, if you have a specific point, will always be in the form of x comma y. So this one, I know the y. All right, so the thing I don't know yet is the x. So I'm going to go back up here where it says x is equal to 11 minus 3y, and now I can substitute the value for y that we just found. So x would be 11 minus 9, so x is 2. So the final answer for this guy, this is where these 2 equations intersect with each other. All right, so the next one we're going to look at is not an example of substitution. It's a better example for elimination. So when you're looking at elimination, you try to decide, do you want to try to get the x's to match, one positive and one negative, or do you want to get the y's to match, one positive and one negative? When I look at this one, I say, well, my y's, one of them's already positive and one's negative. So I want to try to find a number that I can get both of those to. I like to think of it like a common denominator. So when I look at the 2 and the 3, a good common denominator would be 6. So to get each one of those to 6y, I have to take the first equation and on both sides multiply by 3. So that'll give me 9x plus 6y equals -3. The second equation, to get it to a 6, I need to multiply by 2. So again, keep everything balanced, do it to both sides. So I end up with 4x minus 6y equals -10. So now when I add these equations together, the x's will cancel. I have 13x equals -13. So go ahead and solve for x. X equals -1. So there's the first part of our answer. I'll go ahead and put it up here at the top. So -1, and we need to find the y. We're going to do this the same way we did on the last one. We're going to go back to one of our equations, plug in that x value, and that will allow us to solve for y. So I'm going to go to the first equation and plug in the -1. And then go ahead and solve for y. So I have -3 plus 2y equals -1. Go ahead and add the 3. 2y equals 2, and solve for y. So y is 1. So final answer, x is -1 and y is a +1. So if you were to graph both of these equations, they have one solution where they overlap with each other. All right, have one more example. And then we'll talk about the different kind of solutions you could get, and then we'll wrap up and see if you have any questions. All right, so this one doesn't look like a good example of substitution because I probably get some fractions if I try to get the x or the y by itself. So I'm going to go ahead and use the elimination. And in this case, I notice both the x's and the y's alternate signs, so it really doesn't matter which one I try to get rid of. So I'm going to focus on the x's this time. So since one of them is a -10x, I'm going to try to get the first equation to be a +10x, which means I need to multiply it on both sides by a 2. So that gives me 10x minus 4y equals 10. When I bring the second equation down, and I add everybody up, oh, something happens. All the x's cancel, all the y's cancel, and I'm left with a 0. 10 minus 10 is 0. So this is one of the other cases where it's not just a distinct point. And so you ask yourself, is it true that 0 equals 0? Most days, right? Yes. So this means it doesn't matter what value I put in. My solution is all real numbers. So I'm going to show you real quickly what this looks like. And this is a question they like to ask on your test. You have 3 different kinds of solutions with these systems. The first 2 that we get, when you look at the equations that you have, if you were to graph them, I don't know, they have one point where they intersect with each other. The last one that we just did, and then I'll come back to the middle, those were exactly the same equations. So when we found an answer, we got something that was always true. So there's all kinds of infinite solutions. So we usually will say all real numbers, or you'll see us say ARN. The other type of solution that we could have gotten is if we had something when we did the equation and we ended up with, say, 3 equals 5. Well, that's never true. So there are no solutions. So it won't be that you necessarily did something wrong. But on your homework and on your test, you will have one of these 3 types. Either one solution, no solutions, or an infinite amount of solutions. Like I said, this is something you need to know for your homework and for your test. It's a very popular question. All right, so do we have any questions from our home viewers? Nope. All right, well, we'll go ahead and wrap up. If you have any other questions, feel free to stop by the Learning Commons or log on and ask the online tutor at Smart Thinking. Have a great week.